is easier than what the actual questions are, right? It's going to be a bit harder than this, but first we need to understand what we're doing. If you look at your first page here, right, today what we're doing is definite integrals. That means there is a limit set for our integration. Okay, integration, as we know, is opposite of differentiation, but integration has a practical usage of it. Okay, the application for integration is to find the area under a curved graph. Okay, the area under a graph, right? Let's just say let's just say we have a graph like this. Okay, if it is a straight line, then we can just use our normal triangle formula: half times base times height. We are supposed to be able to get the area under the graph right here. But for our quadratic equations, everything quadratic and above, the graph is going to be a curved shape, isn't it? It's going to be a curved shape. Cubic is something like that. Okay, so what we're going to be using integration is to find the area under the curved shape here. Okay, to get the most accurate value under the graph as possible. All right, and that is where you will see these things here, which are basically the limits of it. Okay, if you look at what we have in the first page, you can see that we are evaluating this equation of fx. Okay, in between 1 and 3. Basically, we've set our limits for our graph between 1 and 3 like this, and we are only finding the area under here. Exactly like the application is for you to get the targeted data that you want. Okay, you only want it from 1 to 3 because maybe at 0 to 1, you see exponential graphs, especially 0 to 1, the sample size here would be rather small. Okay, so maybe it's not a very accurate representation of the data. All right, all of these things, of course, later on you guys will learn more in depth of it, maybe in A levels, maybe in calculus. Okay, if you guys choose to do it, okay, but if not, then basically it's useless idea after this. True. All right, so let's look at our questions here today. Now, okay, one thing I need to remind you guys, if you look at this, right, remember last week when we were doing integration, we have the P at the back. Okay, when we're doing limits, right, what we're going to do is first we will substitute, let's say 3, 1, we will substitute 3 into all the x values first. As you can see, 3, 3, 3. Okay, and we're going to minus it off with the second limit here, the smaller value with this example is wrong right here. Here it's supposed to be 1. It's 1, 1, 1 like this. Okay, then you will notice that you did not include the C into the question. How come don't have plus C? Because let's just say in this equation here, right? If I had a plus C and the plus C end up to be 8, okay, after integration, plus C end up to be 8 now, okay? If I plus 8 minus plus 8 here, it will automatically cancel off each other on both ends, okay? That's why when doing integration with the limits, the definite integrals, okay, then you can completely ignore C. If it is not, you must at least put plus C there, okay? But if we're doing with the limits, you can completely ignore C because no matter what number C is, here and here will cancel off each other. Can you get that? Okay? Yeah. Right. Oh, this is just the proper way to represent integration. Basically, we're integrating this equation in terms of x. Integrating this, so basically it's like this, integrating this equation in terms of x. Same thing like what we did last time, differentiate y in terms of x. Like that, remember? So this one is integrate this in terms of x. Just like that. All right, good question. Now, let's look at the examples that we have here. I'll go through a few with you guys, and then you will need to refer to what we've done last week for the methodology of it, okay, to integrate. But basically, the basics of it is going to work something like this. First, in this question here, integrate 3x with the limits of 5 and 2, right? First, when we integrate 3x, it's going to be 3x squared over 2. Now, we're going to put limits on it, 5 and 2. The full working is going to be 3 bracket 5 squared over 2, okay? And then in between, we're going to minus 3, 2 squared over 2, like this. Calculating the actual value here, you would end up with, I'm not going to calculate that, but you're supposed to get 31.5, okay? This is basically your integration with limits, okay? And everything else will follow suit from our previous working, okay? Just that now that we include limits into it only, I would like you guys to try, yeah, don't skip anything out. Let's just try everything out. Today is going to be mostly about this kind of practice only. Then you will notice in the next page, we will start doing the application. Okay, the next page is going to be the application of it. Yeah, if you guys don't have enough space, let me grab you guys some paper. Last week's paper. Oh, you're going to. If whoever is stuck at the question, straight away ask, so we don't waste time looking at it. Yeah. Yeah. Sue me. What are they gonna do? You think we're in USA? We're in Malaysia. Yes, correct. This is whenever you're doing with finite integrals, right? Okay, it's basically finding the area of it already. If you use the visualization of it, because all of this, right? Basically, all of these things we have here, all these equations, they are basically curved graphs. When you're just finding the limits between 5 and 2, 9 and 1, 3 and 2, 9 and 4, and so on and so forth. first, looking at this question, right, what you need to do is you need to solve the simultaneous equation to get your limits here. 10x minus x squared minus 8 is equals to the equation here, y equals to y, right? 10 minus x. Then negative x squared, 10x, bring this x over, becomes plus 11x. Minus 8, bring this 10 over, becomes minus 18 equals to 0. Type this into your calculator, you will have gotten the x value of 2 or x equals to 9. And that's your limit right here, 2, 9, like this. Okay? In fact, if I wanted to, I can find the coordinates of this point also. When x equals to 2, then substitute 2 into here, y will equals to 8. Correct. Then here, when x equals to 9, y will equals to 1. 10 minus 9 equals to 1. Okay, so I have the coordinates of A and B already. Next thing is integrate the curved equation. Okay, integrating this, I would have gotten 10x squared over 2 minus x3 over 3 minus 8x. Okay, and I will then from here set my limits of 9 and 2. After getting 9 and 2, substitute it in here. 5, 9 squared minus 2 cubed. Sorry, what the hell? 9 cubed over 3 minus 8 times 9. This full value minus calculating this. What did I get? $90. Yeah. Please type into your calculator to attempt to see if you got it or not. From here, we know that this full part, not just the shaded region, this full part is actually 88 and 2/3. We want to find the shaded region only. To find the shaded region, what do we do? What? Minus what? What's that? What's the value for the bottom? Using this value here, minus the trapezium at the bottom. That's why we found the height. Okay? So this trapezium has an area, if I draw it out like that, it is 8 to 1, and then here to here is 7. Trapezium formula is half times A plus B times height. This is 31.5. So to calculate the region for R is simply 88 and 2/3 minus 31.5. Did anybody miss any part here? So how do you get that answer? Which one? Which one? 27,106. What do you get? I think 27,106. 27. 爭好遠你知道冇？ And then 106. Can attempt the next question now for those of you who are done right here. Wait, so we write 88, 2/3, right? Let's write 88 times 2/3. No. How do you write 88 and 2/3? There's a button there for you to press on. If you want to put the times, it's 88 times 3 plus 2. Think we go for it. Oh. Yeah. Are you going to need it? Oh, okay. Okay, I'll send it to you later. Hmm? This one. You know how to do or don't know? I'm not sure. There you go. Show them. Don't know if they have finished attempting already or not. Bottom part is okay. Has everyone attempted this question already? Let's discuss on. So in this case here, again, you need to find your own limits, right? Finding your own limits, then what you do is equate both the equations, negative x squared plus 2x plus 24 minus x minus 4 equals to 0. Negative x squared will therefore equals to minus x 20 equals to 0.
Wait, 2x minus x.
Positive x indeed. Negative 1, 120. You have x equals to negative 4 and x equals to 5, of which obviously this is the negative 4 and this is the 5. In fact, we want the coordinates here. When x equals to 5, y will equals to 9. Okay? Then now we are going to integrate this question here. Yeah. integrate this with limits of 5 and -4, negative x plus 24 dx. So you will end up with x cubed over 3 plus 2x squared over 2 plus 24x. Limit them of 5 and -4. The bigger number must always be on top, guys. The bigger number must always be on top. Then that one just simplifies to nothing really, right? When you square a number, guys, please remember that they will turn up to be positive one. Okay. Here. Okay. Union. Correct, I answered you this part. This is the area of the entire region already, right? And then to find the value for r, what we have to do is we have to minus off the triangle here, of which the triangle, okay, is 9 and 9. Okay, so half times 9 times 9 is basically 81. Yeah, well, my answer is not correct already. That's it's wait. Did I type something wrong? My triangle. Let me just. Now, which part did I make a mistake in? Again, where? Oh, you're right. Yeah, it's this part. I made the mistake here. So this one will become positive, right? Oh, genius. So instead, this is negative 58 and so that's why this is -106.
So your laptop, right, the battery, how long will it last to be charged?
Maybe 4 hours, depending if I don't play games. If I play games, maybe 2. It's not a gaming laptop, it's a work laptop.
No, when you play your game, you like charge.
I don't play games yet.
Okay.
But if I have to, then yes.
You keep talking.
Yeah?
You keep talking.
Yeah. This laptop is very good, man. I really started like 1,006 to 1,008 only the time when I bought it. So good, so cheap. Got SSDs and all. Then I upgrade the RAM myself. I integrate negative plus plus 20. Can do like what, Marcus? I don't understand. Can do like what? Oh yeah, that's even smarter. I forgot about that method. Yeah, you can. Yes. Yes. The other method would be to integrate that one straight away. Integrate. The way integrate this and then put the 5 and -4. Yeah, correct. I forgot about that method. Yeah, you can. That's the even faster way because by then you will, after you limit already, right, you will straight away find this region away instead. No need. I don't do the last one. Do the last one next week because this one need to explain a bit. Okay. Yeah. So that will be it already for today.